Okay, Michael, it's top of the hour, so should we get started?
Yeah, let's get started.
Okay, so first of all, welcome everyone to Build With Us webinar with Ascend. Michael and I are both based in Melbourne. I'm kicking us off, but I'll hand across to Michael. I'll be watching chat in case there's any questions. For now, I'll go on mute, observe the chat, and come back to see you at the end. Michael, over to you.
Thanks, Jeremy. Thanks everyone for joining. So this webinar is recorded, and you will get a copy of the recording anyway. But the benefit of jumping on and participating in live events is you can ask your questions. So feel free to use the Q&A function and the chat function in the Zoom recording, in the Zoom sort of UI. So let's talk about, so before we jump into the build, let's have a few words about sort of Ascend and what problem we're solving. So Ascend platform is designed to help the users and organizations to simplify and automate their data pipelines and reduce the overall engineering effort and spend. So you can build and change pipelines faster with Ascend because Ascend's platform uses an intelligent, intuitive, declarative programming model, and it enables faster and easier pipeline development and maintenance. So you can build and change pipelines faster. You can reduce the time and effort required to manage the data operations. We're claiming we can save up to 70% of data platform costs because Ascend's platform is designed to understand the data and the code of the pipeline processes. So it can help you save up to 70% of your data platform costs by avoiding unnecessary data reprocessing. We'll see that in a demo, how it handles that. We can also offer you free ingest into Snowflake and Databricks. That's kind of like straightaway savings, money in your pocket. You will be saving on the ingest licensing and processing costs, including Snowflake-owned Snowpipe costs. So in summary, Ascend platform provides a whole lot of benefits that you can use to help yourself and your organization to improve your data operations and achieve your business goals faster and cheaper. And whether you're looking to build or change pipelines faster, save costs, or avoid unnecessary data reprocessing, Ascend's platform has the features and capabilities. So let's have a look into the actual capability map that needs to be in place to implement data pipelines. So these are the different capabilities that are involved in data pipeline definition and executions. These capabilities are supporting the underlying data platform. So whether it's Snowflake, Databricks, Google BigQuery, and these are some of the tools that are often used to implement these capabilities. So we use a slide typically to frame our discussion and understand and understand and portray what is currently being used in existing data pipeline environments. So the ingest layer is how the data gets into the underlying platform. The orchestration and the transformation layer, they're basically, well, transformation is quite self-evident, right? It's how data being transformed in the underlying platform. And orchestration and scheduling, controlling the timing and sequencing of data pipelines operations. Data sharing is delivering the data to its consumers. Right? So how the data gets delivered, sometimes called reverse-etl, typically a destination database or a SFTP server where your customers can download the files from. And lastly, of the observability features is how you look at data lineage, how you get notified about the errors, how you get notified about this resource utilization, data quality reporting, and so on and so forth. Now, this is what we are implementing all those capabilities that you saw implemented by disjointed tools. We implement them with one single platform at Ascend. It's an end-to-end single data pipeline automation platform, and it enables the users to build and manage the pipelines intelligently in a single place. Ascend provides declarative programming model and a visual data flow. We'll see that in the first demo. It basically provides you a visual data flow graph and enables faster and easier pipeline development and maintenance. There's also a whole range of features that can help organizations to save costs, avoid unnecessary data reprocessing, ensure data quality. It also basically auto-scaling cloud-based SaaS environment that is secure and cost-effective, and it's kind of like one-stop shop for everything data pipelines. Talking about the architecture, it's really a data automation platform. Think of it as a control plane and build environment that orchestrates the data flow into your data plane, whether it's Snowflake, Databricks, Google BigQuery, and orchestrates the flow of data through the platform. Right. Again, the data gets into your data plane. The data stays in your data plane. The Ascend platform simply orchestrates the data movement through the data plane. Okay. Now you use Python or SQL or PySpark, or Snowpark to define your transformations. and the underlying execution of those transformations getting pushed into the data plane. All right, so in our build session today, we're going to look at what Ascend pipelines are built of, right? Look at different components in the sense data pipelines. We'll look into changing pipelines, right? We talked about sort of having multiple tools being involved in data pipeline automation, data pipeline construction that can make the change quite complex. In this case, we're going to see how we can use Ascend to change an existing pipeline, and we'll see a couple of scenarios where we can see the Ascend platform used to basically accommodate data inbound data change or accommodate a code change in the platform. So the traditional challenges we see being present, or the data engineers facing with the existing tool sets. Oops, sorry, jump too far. It's basically the tool sprawl that makes building pipelines difficult. There's a lot of places where transformation logic can be hidden. So it's always kind of challenging to keep in mind where different pieces of your pipeline reside. It's quite expensive to onboard new data. So often business cases to onboard a new data source may not even get off the ground because of the associated costs with data ingest. So that kind of may cause the data pipeline to never be built, because it just there's not enough justification from the business perspective to spend the additional effort and money on building that pipeline. And also reprocessing of the data in the case of data pipelines changing can cause additional costs in terms of the underlying data plane credits or underlying data plane processing costs. So in this overview, we'll have a look at the data pipeline in Ascend. We'll implement a change in one of the pipeline. We'll see how it handles data changes, and we'll see how it handles code changes. So now let's get going with the build. So this is the build environment in Ascend, and you can see the data pipeline being implemented as a direct acyclical graph where the data is flowing from left to right. So on the left-hand side, we have the read connectors. So in this particular case, we're reading the data from an S3 bucket. I'll just zoom in a little bit. So we're reading the data from an S3 bucket and getting the data into Snowflake. Now, if we look at other read connectors, building to new read connectors, you'll see that Ascend supports a lot of different technologies to build these connectors. So it supports the blob stores, different object stores such as Amazon S3 buckets. It supports data warehouses, different databases. We also integrate with CData, which gives us access to close to 200 or 300 different sort of connections to different SaaS systems. We support connections to queuing systems and data streaming such as Apache Kafka, different productivity technologies, and so on and so forth. Right? There's a whole big list of different technologies that we support out of the box to get the data into the underlying data plane. The bits in the middle are the transformations, and in this particular case, the flow that I'm demonstrating is running on top of Snowflake. So we have two types of transformations. So the first type of transformation is SQL-based transformations, where we simply use Snowflake SQL. So we can embed Snowflake SQLs into our transformation steps and have that transformation to be basically run directly in Snowflake in the data plane. The other type of transformations are, in this case, Snowpark or Python-based transformations that are going to, again, run in the underlying Snowflake environment. And you'll see, if I just zoom in and edit that particular transform, you'll see that it's a stock standard Snowpark Python that doesn't really have any sort of Ascend-specific imports. It's a pure Snowpark Python transformation that gets pushed into Snowpark. On the right-hand side, we've got the output connectors, or write connectors, I should say. In this particular case, we're writing directly into a Microsoft SQL server, but we support a whole range of destination systems, similar to what our read connectors support. And we also support data shares. And data shares, think of them as a publish-subscribe connectors to other pipelines built in Ascend. So you can actually trigger pipelines from data shares and have different teams collaborate by building data products using these data shares. So a great way to start building a data mesh in your environment. Okay, so this is the overview of what the data pipeline looks like in Ascend. Let's now go and change. Let's now look at the change scenario. I think the only thing constant in IT is, it's always requirements, always change. And often we build our first version of our pipeline, and The business will be very thankful. Okay, we've got some data flowing. We can see our reports. But hey, there's one thing we want you to change, right? So in this case, we're ingesting weather observations data from S3 buckets, from our S3 bucket. And we want to actually, instead of a station code, we want to get a station name. And guess what? Our station names are actually sitting in a Postgres database. So I actually need to do a join. So to be able to do a join, I need to bring, first of all, to bring the data in, right? So we'll create a new read connector. And we'll use our existing Postgres connector to basically browse to the table with that contains the reference data. Let's go and select the table. Here's my weather station demo table. I'll pick a user-friendly name for that read connector. I'll click on generate schema. So this a platform's going to go into my Postgres database, bring back the column names and column types and a bit of a sample data just to kind of illustrate what it's going to bring. Okay, now we can see the column name, the column type, and the preview of the data that's going to basically start flowing into my Snowflake environment. This is where we can define data quality checks. We can also define the refresh schedule. So I'll hit create, and you'll notice once I hit create, the data will start flowing immediately into my Snowflake environment. Okay. So now I'm going to go and define my transformation. Right, I'm going to paste my join statement. It's a fairly simple join statement between the two read connectors. So the only thing to notice is the double curly bracket syntax where we connect to the preceding or to the previous steps and using it as a table name, right? So it's like a templated syntax to use step definitions as table names. I'll hit create, and we can see basically the new flow basically forming in our screen. So I can see that the weather station data finished the loading. The read connector finished loading the data into Snowflake, and we can see that the weather transformation step now kicking into a gear, and then basically now the two of them are marked complete. So now what I want to do is I want to change my flow and make the subsequent steps basically receive the data from the new transformation that I just defined. So using the sort of a type ahead, I can select the transform that I just defined. It's right here, the weather stations transform, and I'll hit update. So that you can see that updated my flow. Now the two preceding steps, they actually stay the same. So there's no reprocessing. There's no unnecessary reprocessing happening in this case. We can see that only the downstream steps are being affected and being rerun. So this is one of the kind of features of the platform where we sort of intelligently understand the underlying data and understand the code changes to be able to reprocess only the steps in the flow that are affected by that particular current change. So we're going to look at a couple of other change scenarios shortly, but in this case, we can see the subsequent data flows, subsequent data flow steps or pipeline flow steps are being run, and that's it. So this is the change, right? So we can see the change making its way through the flow. If we look at the schema, the resulting schema will have the station name, the new field that the business asked us to add. So we have the station name populated in our output schema, and we can see all the records, alongside the station code, they now have the station name. So we kind of that's the change that the business asked us to implement. Now, if you think back to your existing data stack or the data pipeline stack, and you think about all the steps you need to do in sort of this disjointed world of different tools, you probably need to, define the new read connector, update your scheduler to, trigger that read connector, but also trigger all the new transformation step, update your data lineage documentation, update your tests, update the schema definition at every step, rerun the tests, rerun the entire pipeline to make the change actually take effect. Long and convoluted process that may take hours and days, right? Something that we've managed to implement in Ascend in just a few minutes may take a very long time. Your traditional modern, what we call modern data stack, modern data pipeline stack. So we've just seen the changing of the flow. Let's see how Ascend responds to change in the input data, right? So just to a couple of words about how we handle the input data. So Ascend handles basically partitions data, right? Because in big data, it's a traditional technique to deal with sort of arbitrary size of input data sets. So we partition the data, and in this case, we create a new partition. So if we look at we look at the input step and look at the partitions tab, we're creating a single data partition for each CSV file that we ingest into the platform. And using partitions, we can avoid reprocessing partitions that don't change. So only reprocessing partitions that change, basically. So in this case, if we change one of the files, we'll see only that file, only that partition that corresponds to that particular file, CSV file, will be reprocessed by the data flow. So let's just do exactly that. So let's go and change our S3 file. So I've got it basically deployed locally. So I've got a directory that's synchronized with my S3 bucket. So I'll go in and I'll just change one of the lines in my CSV file. I'm going to save it to disk, and I'm going to sync it with my S3 bucket. All right, hopefully the sync should be, it's a relatively small file. Yep, completed. The sync is done. Now, ideally, this change will be picked up automatically if I define a refresh schedule. So every, say, 5 minutes, for example, the connector will check for new files. It'll discover the file being updated, and the reprocessing will just happen. So in this case, I'll just hit a refresh. I'll hit a refresh manually. So when I hit refresh, it'll go back to my S3 bucket. We'll validate whether one of the files changed, or whether the files changed, and we'll start reprocessing, and we'll see what happens. So by the way, the weather station reference data is not changing, so there's no reason to reload it. We can only see, so we can see that 4 out of the 5 partitions, they stay the same. One partition is detected as a changed partition. So we can see only that partition being pushed through the flow and being reprocessed all the way through the flow. So this is how we handle reprocessing. So only that partition takes, so the reprocessing of that partition takes effect throughout the flow. Okay. So while the reprocessing happening, do you have any questions? Do we have any questions in the chat, Jeremy?
There are 2 questions. I'm going to leave until the end.
Okay.
Let me go and check. One question was, you said free ingest. Is that free as in free puppy?
Yes, you essentially get all you get all the credits from basically the underlying data plane, Snowflake or Databricks. You'll get it all back from basically through Ascend. So yes, it is a free ingest into Snowflake and Databricks.
Yeah, and to answer that question, it's free forever, right? This is not like some special offer. This is free. The second question was, does Ascend use an orchestration tool, something like Airflow behind the covers?
Nope, that's it. This is the only tool you're going to need to build your pipelines. There's no other orchestrators. There's no other transformation tools required. Yeah, it's what you see is what you get. It's one environment, one tool to use to build your pipelines.
Great. They're the only 2 questions. Any other questions? Please drop them in chat.
Cool. Let me just go ahead. I just noticed something. We have the weather stations transform, handling basically consolidating all the partitions into one. It's one of the techniques, but we can, for example, define the flow to work on each partition separately. So in this case, we're reducing all the partitions into one partition. We can effectively map partitions one to one. That will cause all the partitions to be handled separately. Let me just redo the change. Be real quick. Save. You can see that it actually split the processing and only doing the reprocessing from that particular step. Downstream, typically, you're not going to merge partitions for just a straight through processing when you're not reducing the input data set using like aggregated functions such as max or average, right? So you can actually, if it's just a simple join, you may want to preserve the partitions as they come from the input data source. So let me just, the change is flowing through.
I'm learning something here, Michael. So basically what you're saying is that if it wasn't 2 million records, it might be 200 million records. You're partitioning it in the ingest. And then if you keep those partitions, then the reprocessing at the transformation steps is only going to be on those partitions that changed. But if you hadn't done that, they'd all be in one partition. So it would always, the whole thing would always be.
We'll reprocess everything downstream. So in this case, let me do the same change again. I'll change a single data point just to make sure that the file is going to get detected as changed. So I'm going to sync it back into my S3 bucket, and just check if it's done. Yeah, the sync is complete. So I'm going to refresh my raw weather data.
What we want to see is one partition's identified in the ingest, but also one partition changes in the transform.
Yeah, so you'll see everywhere where it said 5 partitions, it'll be just 4 unchanged and 1 changed, right? So we see 1 and 4, and we're going to see the same thing flowing all the way through the flow. If we're not doing so, for example, max sensor reading by day, it's by definition is going to consolidate the data set into one. So some of the aggregated functions will cause the data to be consolidated into 1 partition. Other steps basically will keep the number of partitions as 5. You can see 1 and 4 flowing where it's actually applicable, and then in the max sensor reading by day, it's going to be consolidated into 1 partition. So it's kind of handling the partitioning flowing all the way throughout the flow. Right. So it's now updating the SQL Server, and this is the change in the input data. So one of the files changed. There's no need to reprocess the other 4 files. They can stay the same. So we only process one file that had the change in, and we're saving on reprocessing costs. So this is one way how Ascend helps you save on the underlying processing costs. So alongside with the free ingest, you also get a very sort of clever way of just reprocessing only the partitions that changed. Let's see how Ascend handles a change in the processing logic. So for that, I will change a logic in the middle of the flow. So we'll edit our precipitation definition, and we'll just change the threshold, right? So, something happened to the precipitation definition, and we want to put it as 0.75, right? We think there has to be a more significant rain for the day to be considered rainy day. So we'll hit update. And again, in this case, you'll see that the upstream steps, they're staying in the up-to-date state. And the only change that is happening in the pipeline is the step that changed and everything downstream from that step. So we kind of intelligently reprocessing data only from the point where the code in the pipeline changed all the way down to the write connectors. So without sort of having to reprocess the pipeline steps or the data that represents the pipeline steps where the code stayed the same. Right. So this is another way of Ascend avoiding unnecessary data reprocessing costs. Okay, so now we finished reprocessing the data. This was the final change scenario I wanted to demonstrate. So in summary, so we just saw that what pipelines look like in Ascend, how easy it is to build and change pipelines, and it can definitely be directly linked to some of the operational benefits, right? So you can build pipelines easier and faster. You can change them. It's a single data pipeline, that can be used by your data engineers. It supports a very declarative way of configuration. So there's not a lot of you don't have to define how the pipeline should function and how the pipeline should read or process the data. You mostly define what should the pipeline do, such as very declarative ways, such as like SQL, right? You want to keep the same sort of build approach as you use with SQL. You want to define the transformation of SQL, and that's exactly what the platform is going to do. Intelligent control plane that allows you to sort of confine the blast radius of your change, confine it to the place and the place in the pipeline and where the change occurred, and the steps downstream from that particular step. Reprocess only the data that changes. And last but not least is the free ingest into the platform that we offer for Snowflake and Databricks data planes. Some of the observations from our customers, right? We are seeing our customers achieving some game-changing efficiencies by using Ascend. We're seeing 67% reduction in tool costs because we're allowing you to consolidate all the different tools into one platform. So if you remember ingest, transformation, orchestration, sharing of data, observability, instead of having multiple tools for all those functions and capabilities, you can use one tool in one platform. Use a single platform to consolidate multiple tools. Around 63% of reduction in underlying compute costs through the use of this intelligent ability to detect change and only apply change in the places in the pipeline where it's actually relevant. And then we're seeing 7x increase in pipelines productivity per data engineer. So your data engineers can do more with a single platform compared to their existing tool stack. So with all that,
thank you, Michael. We're at time for the session today. We've got no more questions. It's great to see the audience and I can see some attendees who joined us at the Snowflake event 2 weeks ago, and some people from Databricks. So we're running these live webinars once a week. Very happy to engage with anyone who wants any follow-up. I've learned something today, so thank you for that, Michael. Very excited to talk to more customers. If you want to follow up with us, you can reach Michael, mike@ascend.io. Thank you for that, and we'll end the webinar there.
Thank you all.